All right. So following a success, the Republican now knows 2 points in the mapping. He knows this one and this one. And in particular, he knows a point that's now only 1 unit from his ideal. All right, so now he faces a choice. There's no point doing a huge experiment anymore because he's not so far from his ideal, and so he'd only do a small experiment. He might move 1 unit, which could give him his ideal outcome, or it could move it 1 more unit away. All right, turns out in this case that R, despite not getting his ideal, wants to stop and not experiment anymore. All right, so in a sense, the outcome essentially is good enough for R. He's only 1 unit away. He says, that's good enough, I don't want to experiment anymore. So in a sense, the small experiment of the D in the first period headed off a big experiment in the second period. All right, and so that's good for the Democrat in that the R is not engaging in a huge experiment in the second period. He's only going to end up, at most, 1 unit away from his ideal. All right, so that's the case when the first period experiment is a success. I've got to tell you what happens when the first period experiment is a failure, in the sense that it went opposite to what I expected. Now the logic's reversed. The point that the Republican knows is now 3 points from his ideal, and so his optimal experiment is a huge experiment, which is even more costly for the Democrat. Right? But fortunately for the Democrat, the comparison isn't a huge experiment in this point, or for the Republican, it isn't a huge experiment versus this point. It's a huge experiment versus this point or that point. And so whilst the Republican won't choose this and prefers to experiment instead, turns out he prefers to choose this rather than experiment. All right? So the fact that the Republican now knows 2 points rather than 1, and one of those points isn't as bad as the other, means that the Republican actually doesn't want to experiment, but instead backslides to the previous known point, the status quo, all right, and chooses policy 0. So in fact, and what you'll know, of course, is that that's the Democrat's ideal outcome. So in fact, D is better off if his first period experiment fails. All right. So in aggregate, we've got a small experiment that could head off a big experiment. If it succeeds, and if it fails, it actually makes the Republican less inclined to experiment and the Democrat gets his ideal. All right, so you put those two together, and in aggregate, this makes it profitable for the Democrat to engage in a small experiment or a preemptive experiment in the first period. All right, so for the sequence DR, we have 4 possible cases. The case I've just run through is this third case here. All right, so that's the only case where the Democrat preemptively experiments. For low Q values, for really complex issues, the Republican won't experiment, so there's no point the Democrat experimenting. For the next, on a small range of issues, the Republican's only going to choose policy 1, so there's no point engaging in a preemptive experiment of a small experiment, so the Democrat does nothing. And in this range, the Republican's going to do a big experiment, all right, but with high probability, with high value of Q, the Democrat's confident the Republican's going to get what he wants, he's going to get a good outcome, he might as well take his ideal outcome in the first period. All right, the Republican isn't going to get stuck. Even if you have a failure in the first period, he's going to keep experimenting, so you might as well take your ideal. All right, so there's no experimenting by the Democrat here, no experimenting here, but for a range in the middle, the Democrat finds it worthwhile to preemptively experiment with their policy. All right, so this preemptive experimenting is moving the expected outcome away from the Democrats' ideal towards the Republicans, all right, and that's towards the voter as well. All right, so by preemptively experimenting, the Democrat is moderating his policy for complex issues. All right, and this is exactly what the voter wants. So for sequence DR, or sequence DR, I should say, implements the voter's ideal policy program when Q is in this range. All right, it also does it when Q is in this range because then nobody experiments, and that's what the voter wants. All right, but what's important is that this range where we get preemptive experimenting, that turns out to be the sequence that the voter precisely wants. All right, so it's in that sense that this preemptive experimenting is creating the link across periods and serving the interests of the voter. All right, through a bit. All right, so pushing that further, I can show that this is inducing some moderation in the policy. All right, it's moving the expected outcome towards the voter's ideal. And what you'll remember is I said when the mapping is perfectly known, there was no moderation whatsoever. All right, you put these two effects together, by adding some uncertainty, you're adding some risk, but you're also getting moderation. The benefit of moderation outweighs the risk of the uncertainty, and this leaves the voter better off than if the mapping was perfectly known. So in a sense, the uncertainty here is kind of inducing some control over these politicians, and that serves the voter's interest, and it outweighs the risk of the uncertainty. All right, so that's the main result for the sequence for the simplest possible case. All right, and we can run through the other sequences and so forth, and you get some interesting effects, but this is the main one. All right, before I kind of move on to the more general case, we can also talk about what happens when we have symmetric uncertainty and the status quo is known to be 0. All right, so what I want to show you is that this alternating power in this setting also benefits the voter. So it's not just we start with a kind of divergent known point and we're trying to move it towards the 0, towards the voter's preference. Even if we start with the known point being the voter's preference and the voter's got to assign power to the Democrat or the Republican, they're better off alternating power. All right. So in this case, we know the voter's ideal outcome, the policy that gives the voter's ideal outcome. So the voter's preferences is to minimize experimenting. In the last round, he was trying to induce experimenting. In this case, she wants to minimize experimenting. All right, so what happens here? Well, the Democrat's ideal outcome is negative, so he wants to move policy to the left because that's more likely to move policy. This in expected value, it's moving it down. The Republican wants to move policy to the right because in expected value, that's moving it up. All right, so in a way, you might think they're operating in different parts of the policy space here. The Democrats wants to go left, the Republican wants to go right. All right, so just like that. All right, so well, what happens, we'll think again about this sequence DR. So suppose D is in power in the first period. If D experiments to the left and gets an outcome down here, so a success, it moves where you think it's going to move to in expectation, that information's not useful for the Republican, so the Republican in the second period is just going to experiment if it's worth, so that should be Q and 1 minus Q, is going to move to the right if that's worth the Republican's interest. All right, so a success, again, kind of doesn't have, in this case, has no impact on what the Republican does. All right, however, if you have a failure, if the Democrat moves 1 unit to the left and the outcome goes up, not only is that bad for the Democrat in the first period, right, that tells the Republican exactly what policy gives the Republican's ideal outcome. So consequently, in the second period, the Republican would just repeat policy -1 because he knows that gives outcome 1. So in a sense, the Republican would abandon his ideology, where his ideology is telling him move to the right to get a more conservative outcome. Just by happenstance, the Democrats revealed a point that gives him his ideal outcome, so he's done. All right, so what this means is for the Democrat, if he experiments in the first period and has a success, he gets that for 1 period, then the Republican does what he likes in the second. But if he has a failure, he has to suffer that cost in both periods. All right, so this is the reverse of kind of the option value logic, where you experiment because if you get a benefit, you get to keep it forever, and if it fails, you can throw it away. This is saying if you fail, you get stuck with it for 2 periods, but if you succeed, you only get it for 1 period. So a failed experiment in this case is, in a sense, doubly costly. You get it for both values, so experimenting has a negative value.